Okay, welcome back. We're going to be doing lesson 1.2 now. This one's going to be talking about grade. No, not the grade that you're going to get. It's a different meaning for that. Angle of elevation and distance. All right, so as a review, let's think about the Pythagorean theorem. So that's all that triangle stuff, right? So if we look at the Pythagorean theorem, what we're going to do is think about a triangle. So that's all it says in right triangle, and then it says triangle ABC. That's not changing this time. I know we just finished talking about how that delta symbol is changing. In that case, it's just saying triangle and then A, B, and C. The Pythagorean theorem states the following: a squared plus b squared is equal to c squared. So it's talking about the lengths, right? The tangent ratio is a trigonometric ratio that applies to right triangles. It is a ratio of the side opposite an acute angle to the side adjacent to the angle. For angle A, the ratio can be stated as follows. So tangent, before I move on anymore, let's make sure you know what I mean by tangent. In your guys' calculators, yours will probably look something like this one. You'll have similar buttons. You can see this button here, right? Tan, T-A-N. That's what we're talking about. So tan. So if I start over here, I could go like tan of 3 divided by 4, and I get, no. So before we go any farther here, I just want to show you what this like tangent thing here. So tangent of angle A is equal to length of opposite side over length of adjacent side. Just before we get going, I just wanted to show you what that tangent even means. So you're on your calculator, which will look something like this one. It's talking about this tan. So that button right there, T-A-N, tangent. So that's the one we're going to be using quite a lot here. That's going to be equal to, and it says length of the opposite side over length of the adjacent side. So shortened, it's gonna be this. Tan A is going to be equal to opposite over adjacent. So let's go back to our triangle and figure out what it's saying. So tan A. So the capital A here is referring to this capital A. So it's saying, what is this angle? So this is the angle we're talking about right now. Now, I'm not sure if you remember how to name these things, but the adjacent side is going to be this side. And think it's the side that is, well, the word adjacent means beside, right? Like if something's adjacent to something else, you're saying it's right beside something else. It's right beside that angle. So that's why it's adjacent to that one, right? So that we're talking about this. The opposite, so OPP, that's opposite of the angle. And then the last one we have is the hypotenuse. So, but it's not coming into play right yet. So those are our three names that maybe you've forgotten, maybe you've never seen. Yeah. So now our equation that we have is going to be tan of that angle, so whatever angle that is equal to this side divided by this side. So that's all it's saying. So when it says tan A is equal to A over B, it's just using, A over B now. All right, so I think this will make a bit more sense too when we start using it with numbers. So let's do example 1. It says use the diagram to calculate the following. The length of the hypotenuse, so that's this, right? The long side of a triangle is the hypotenuse. So let's do that first. So use Pythagorean theorem. So a squared plus b squared is equal to c squared, so that one. Zoom in maybe a bit here. And then all you're going to do is just substitute the numbers in. So a in this case, let's make sure we know what a is. So a is going to be on this side. B is going to be on this side. And it's kind of, a line goes from A and then lowercase a is on the other side. So capital B, lowercase b's on the opposite side of that. So that's kind of how that works. But this doesn't really matter anyway. You could put whatever one you want in there and whatever one you want in there, right? Because this could just as easily say b squared plus a squared is equal to c squared. They mean the same thing, right? So all you got to do is make one side squared, make the other side squared, and that's equal to the hypotenuse squared. So that's the important bit there. So then just plug your numbers in. So one of my sides was 2.5. Square it. Make sure you go 2.5. And then hit the squared button. So on my calculator, it looks like this, x to the 2. So that's 6.25, right? And then 3.9 squared, 15.21. That's equal to c squared. then the last thing, or not, well, second last, I guess, make sure you add these two numbers together, which is 21.46. You're not quite done yet. What you have to do to figure, like this is what c squared is equal to. That's obviously not the answer, right? There's no way that this would be 21.46. That's way too long comparing it to those two numbers. So the last thing you need to do is take the square root of it. That's what that symbol is, right? And the reason why that works is because you're taking the square root of both sides of your equation. If you do that, taking the square root of c squared cancels that square. So you end up with just c. So c is equal to approximately 4.6. That's what those squiggly lines mean. It means it's about 4.6. And it's only about 4.6 because they just rounded the decimal at the end there. Okay, so now let's do B. And this one's just going to be like making sure you do it right in your calculator mostly. So it says find the tangent ratio to solve for angle A. So it's just saying like what is this angle, right? So here's our formula. Tan A is equal to opposite over adjacent. We just got to make sure you get the right one and the right one here. So if we're looking at this angle, that's the symbol for an angle, theta it's called, then adjacent is going to be the side close to it. So adjacent, that's going to be that one. Opposite is going to be this side, so OPP. So we just need to make sure it's opposite over adjacent. So it's going to be 2.5 over 3.9. So that's what that is. So that's how we set it up, right? That's step number one. Now, this part, it says, if I want to go from tan A is equal to 2.5 divided by 3.9, and I want to change that to what is A there, like what's the actual A, what you need to do is something called the inverse of tangent operation. And that's what this little -1 up at the top means. It means that you're taking the inverse of tan, and that's going to give you what A is equal to. Now, how do you do that? Well, you guys' calculators are all kind of different. On this one, I wish it it doesn't actually give me the option for the inverse of tan, right? It just says tan. I don't have tan to the -1 symbol. But on my scientific calculator here, if you have one of these, great. If you don't, it doesn't matter. We'll figure it out. You can see like under trig, I've got options here. So I've got tan, and then I've got tan with a little -1. So what I do is go tan -1. Oh, didn't actually press it, I guess. Okay, there you go. Now I finally got it. Okay, so tan -1. Hopefully it's not too small for you to see. And then you could actually just go 2.5 divided by 3.9. Push enter. And then there you go. 32 point, and round this up to 32.7, like our answer shows down here. So that's the way it would look on a scientific calculator like this one. If you've got just a normal calculator here, let's see if I can show you. Okay, so let's see if I can show you here. So if you had one like this, well, it's all backwards. You can see under tan, right there, right? Up above it, there's that green tan to the -1. So all you have to do on this one, our numbers, what were our numbers? I gotta check again. So it was 2.5 divided by 3.9. We're gonna do that first. So just write your calculator. The first step is you go 2.5 divided by 3.9. Okay, so go. Still see it? Yeah. 2.5 divided by 3.9. Right? And then just push enter. And you can see that you've got this like decimal number going down there. Now all you got to do is we need to get that tan -1. So it kind of does the opposite of my other calculator, right? So you find the number first, and then what we're going to do is I'm going to push second, and then tan, because that gives me the green one up there, right? Tan to -1. So second, and then that one. And then I've got 32.66, so 32.7, so same thing. So hopefully that made sense. Here, let's go back. So find the number, and then do tan -1 if you're using a calculator like this. If you're using a fancy calculator, you can just type it in pretty much exactly like it looks. So just a little bit different on what kind of technology you're using. All right, so there you go. So hopefully you're able to do that now. Okay, so I'm gonna let you guys go ahead and do this. All you gotta do is find the indicated side. So it's always gonna be the hypotenuse in these ones. So you're using Pythagorean Theorem to find that. and then you're finding this angle. The only thing that I think you could maybe get confused about is messing up your opposite and your adjacent sides. So let's say I was looking for G here. Which side is my adjacent and which side's my opposite? Well, adjacent is going to be the one that's close to the angle, so that's this one. Adjacent. Opposite is always on the opposite side, so that's going to be opposite. Just notice here that, let's say for a second, I was looking for this angle instead. Let's say I was looking for this was on the side I or something. Or angle I. Then notice that they swap. Now this side is the adjacent side, and this side is the opposite side. They've swapped places, right? So it does matter which angle you're looking at. These adjacent and opposites aren't going to be the same for every triangle. It depends on which angle you're actually looking at. Okay, so go ahead and do those questions on your own, please. And so pause it and then continue on after you're done those. Okay, so new skills, working with slope and the tangent ratio. So with this triangle, we've kind of gone over how, this would be the rise, and we can call this the run. So x is the rise, y is the run. So we can write an equation that looks like this. M is equal to x over y. Now the tangent of x, of angle x, so we're talking about the tangent of this angle right there, is the ratio of the opposite side x to the adjacent side y. So x over y, they're the same, right? So then if that's true, then we have to say that m, the slope, is also just equal to the tangent of that angle. So that's kind of our new kind of thing that we can learn there. It'll make a bit more sense in the example in the next one though. So with this one, example 2, find the slope of the hypotenuse as a fraction and then use it to find the angle of elevation. So find the hypotenuse, or the slope of the hypotenuse, sorry. So rise over run. So if we do that, we've got rise over run is going to be 6.8 over 4.2. Now all we've kind of done here is just to keep it as a fraction, we've just kind of eliminated decimals, because decimals kind of suck if we don't need them. And the way we eliminate the decimals is you can just multiply the top, 6.8 times 10 and the bottom by 10. And what happens is now this just turns into 68 over 42. Right? So now we just got rid of those decimals. And then the last step we'd want to do is just simplify this fraction. So we can divide the top by 2 and we can divide the bottom by 2. And we get 34 over 21. So this is our slope. So m is equal to 34 over 21. Now remember that tangent of that angle that we're looking for, this one, that's equal to the slope. Tangent of that angle is equal to the slope. So we can say tangent of that angle is equal to what we just found here, that slope, 34 over 21. Now you just need to use your calculator to do that inverse tan thing to figure out the inverse tan of 34 over 21, and that's 58.3. Before I move on though, I just want to make sure that this didn't confuse you with why we did this whole first part here. It wouldn't have mattered if I took, like over here, so we said tan theta, or tan of the angle, is equal to 34 over 21. You would get the exact same answer if you went tan theta is equal to, and just put this one in, even with the decimal. It didn't need to be, our simplified version without decimals. You'd get the exact same answer if you went tan theta is equal to 6.8 over 4.2. What you get for theta would still be 58.3 degrees. So don't let that part confuse you. We just did that just because we kind of like it at neat and tidy slopes instead of decimal slopes if we can. Okay, so I'm going to let you guys go ahead and do these ones on your own. Just remember your formulas here. You'd have slope, so m is equal to rise over run, and you're going to have tan theta is equal to rise over run. Okay, so if you're going to find your slope, use this one. If you're going to find your angle use this one. All right, so we're going to learn a new thing here now. Something called grade. So percent grade, maybe you've seen signs like this before, especially if you've been like an old, steep roads out west maybe. What this refers to is it's just a way of saying how steep something is, especially for these big trucks. They don't want to be going down these really steep slopes that they might not be able to stop because they weigh so much. So we talk about it as a percent grade, and the only difference here, like we've done rise over run as our slope, right? Now what we're doing is we're just multiplying by 100. So if you had a slope of, let's say you had a road, maybe I'll draw a road over here, and you got a truck going down it. But that's probably, like, if you think about a road, that would be extremely steep, right? So a road would be, more like this. Like even that would be a pretty steep slope. And let's say that it went down 4 inches for every 100 inches, right? So that's the kind of slope you're dealing with there. Then the slope of this thing would just be, so m is equal to rise over run, so 4 over 100. So we're going to get a decimal there, right? So if you go 4 divided by 100, because that's what over means, you get 0.04. So our slope is 0.04. Now if I want the percent grade, all I got to do is multiply by 100. So we'd say this thing had a percent grade of 4%. Okay, so that's kind of the idea there, right? So this question says, what's the slope of the road as a fraction? So part A, we just went, well, start off with your new formula. So percent grade is equal to rise over run times 100. And then plug in what you know. So 7%, maybe I'll zoom in here. Yeah, 7%. So it would go under the percent grade. And then rise over run goes over here. So rise over run. And that's equal to rise over run times 100. And then if I want to get rise over run on its own, because that's what slope is, I could just divide both sides by 100. So divide by 100, divide by 100. And now I've got rise over run is equal to 7 over 100, or m is equal to 7 over 100. Slope is equal to 100, or 7 over 100. The other way to think about it, though, is that 7% grade, you could always just remember that that's kind of referring to what the rise is going to be. That 7 just means that the rise is going to be 7, and the run is always going to be 100 when we're talking about percent grade. So just when you're doing these, just always think about the run as being 100, and then whatever this number was, that's what your side value is. And then just look at that and say, okay, well, rise over run, that's 7 over 100. Okay, and then use the tangent ratio to solve what the angle actually is. Well, that's just what we've been doing, right? So you can, you just need to use that inverse of tan thing again with 7 over 100 to get 4 degrees. So now number 6 here, though, let's just be careful because it says Heckman Pass is a very steep section of highway connecting Anaheim Lake and Bella Coola, BC. At the steepest section, it rises 900 meters over a run of 5 kilometers. What is the percent grade of this section? So what we need to make sure, though, is that these are in the same units. It's not going to make sense if we've got one in meters and the other in kilometers. So what I would probably do is change this kilometers into meters. Do you know how many meters are in 1 kilometer? It's 1,000. So there's 1,000 meters in 1 kilometer. So this, I can even just cross it out right now and just say, well, this is 5,000 meters. So now what is the percent grade? So percent grade is equal to slope. So just find your slope and multiply it by 100. So rise over run times 100. I'll let you guys go ahead and do that now. Okay, I'll let you guys do this one too. Just one thing that I don't want to confuse you. 2.5. Would you keep it like that, or would you write that maybe a little bit different, like maybe as a decimal to make this a little bit easier? What is 2.5 as a decimal? So I'll let you guys think about that one. So now number 8 here. Again, what I would do if I was looking at this, as soon as I see 13.5 and anything to do with a percentage, what that's talking about, so 13.5, I know that my run is 13.5, and I know my rise is 13.5, and my run's going to be 100. That's really what that means, right? So 13.5 is just saying that how much does it go up for every 100 meters. So that's kind of where my starting point would be on that one. Okay, now pitch. So pitch really is just slope. There's just more words than there should be that kind of for the same thing. Pitch is really usually when we talk about a roof on like a building, you'll talk about like what pitch is that roof. But it really just is saying like what's the slope of that roof. So don't overthink that one. Okay, so looking at this one now, it says how wide is the shed in the diagram below if the pitch of the left side is 3/4, slope, because it just as easily said, and the pitch of the right side is 8 to 9. Okay, so this side, the slope, m, is going to be 3/4. This side, it's going to be 8/9, or 8 to 9. Okay, so what I'm going to do on the left side here, I'm going to do on the left side of the house, is we're going to say, I'm just going to write that down, 3/4. So that's what my slope is. That's got to be equal to my rise, whatever h is, over my run. So I'm going to be able to figure out what h is if I do this. So let's rewrite this now. It's just h, my rise, over 3.2, right? The slope has to be that. So what is h? And then what we're going to be able to figure out once we figure out h is we can use that to figure out L. That's kind of our missing info here. So let's go ahead and figure out what h is here. So I'm just going to cross multiply. I'm going to go 3.2 times 3 divided by 4. That's going to give me h. So if you do that, you get 3.2 times 3 divided by 4. We get 2.4. So 2.4 meters. Okay, so that's step number 1. Let's put like a box around that maybe just to know where we're at. And just put the reason test to this too. When you get numbers, if you got a number like 12, would that be right? Like I know it has to be less than 3.2, right? It's got to be somewhat less. So 2.4, that seems in the right ballpark. So I'm probably right on that one. All right, so now I know this is 2.4. I can even just like fill in 2.4 up here. So let's write 2.4 meters. Now what I'm after is the length of this thing. So let's kind of do part 2 over on the right side here now. So I'm going to write down 8/9. That's the slope of this roof, right? And that's going to be equal to my rise over my run. So 2.4 meters over L. Now I'm just going to go 2.4 times 9 divided by 8, and that's going to give me L. So 2.7. 2.7 meters. Okay. Now last step here, it wants to know the actual width of the building. So that's going to be L plus that side. So I just need to go this plus 3.2. So total length, I'll just go capital T, is going to be equal to 3.2 meters plus 2.7 meters. So T is equal to 5.9 meters. And if you flip to the next side, you can see here's the them doing the same thing. I just find it a little bit easier looking, doing it step by step like I did on like with the picture there. All right, let's move on. So these ones are going to be a bit more problem-solving ones that you might find a little bit tougher. It might bend your brain a little bit. But that's good. So I want you guys to kind of work through these, struggle with them. That's how you learn. And then practice your new skills. So we're going to go through and do the rest of these as well. So those ones, those ones, those ones, those ones. And then don't do 3.2 yet. Stop before you get to there. All right, so I'm going to end that video there.